All right, so we did Vieta's formula for quadratics last time, and we're going to look at the formula for cubics. Now, if you do a little bit of research, you'll notice that Vieta's formulas all kind of like lead into each other. So there's a lot of stuff for cubics that are going to look similar for quadratics, and then quartics will look similar to cubics, except there's like combinations involved, which we'll talk about in a second, and then you can kind of see how they're all kind of like related to each other. So once again, Vieta's formulas are used not to find specific roots, but really to find like solutions to problems that's asking about like traits of the roots of polynomials. So if it's a cubic, obviously we should have 3 roots rather than 2. So this time we're going to set t, y, and z to be the roots of a cubic polynomial. And just as a reminder, this is what a cubic looks like. So very similar to the standard form of a quadratic, but a is now going to be on the cubic term, b will now be on the quadratic term, c will now be on the linear term, and d will now be the constant. And if we went to a quartic, it would be the same thing, except a would be on the quartic term, b would be on the cubic term, c would be on the quadratic term, d would be on the linear term, and e would be the constant. And this kind of continues in that kind of pattern. So the sum of the roots is exactly the same as it was for a quadratic. It's going to be negative b over a, where b is going to be the quadratic term and a is going to be b is going to be the coefficient on the quadratic term, and a would be the coefficient on the cubic term. Now, as we add more roots and degrees to the leading term, what happens is that we start getting more equations. So with the quadratic, we only had 2, which was the sum and the product. But now that we're adding a 3rd root, we now have a 3rd equation, which is actually the one in the middle. So in this case, we're talking about combinations of any 2 roots. And this means if we were to have any 2 roots, combination of any 2 roots multiplied, actually, let me rewrite this. A combination of any 2 products of the roots. Any 2 roots products added together. Now you think about this, right? We have 3 roots, and I want to figure out how many ways I can multiply 2 of those roots together. Well, this is just a combinatoric of 3 choose 2, which is just 3 times 2 divided by 2. And we got 3 different ways to multiply 2 products together. So for example, with our roots of t, y, and z, the 3 ways we can do this would be t times y, t times z, and y times z. And those are the 3 ways that we can multiply 2 roots together. And what do? We add them together. And what does that simplify to? That simplifies to c over a. And remember, c is your linear coefficient over your cubic coefficient. And if we wanted to find the product of all the roots, so this would actually be kind of like that rule that we had for quadratics, where it ended up being c over a, but that's because it's a combination of just 2 choose 2, and so there's only 2 equations here. For this one, this is going to be t times y times z is equal to negative d over a. So quadratic is a special case for the product of roots. Every time we have it after, it's always going to be the negative constant over the coefficient of the leading term. So we're going to leave with a practice question. We're actually going to stop the video here because I want the math team that's in front of me to work on this, and then we'll post up a solution to this problem after. This is the question we're going to work on.